Okay, section 2.9 is writing chemical equations in the textbook. So a chemical equation is a symbolic representation of a chemical reaction in terms of chemical formulas. You have two sides of a chemical reaction. You have the reactants, which if you can look in the lower right-hand corner of the screen, I have this. So in this reaction, two hydrogens and an oxygen goes, those are my reactants. The right side of the equation is the two waters. Okay, there's no limit on the number of reactants you can have or the number of products that you can have. Okay, and then the other part is that a coefficient, which is a number in front of the formula. These coefficients here, which I don't have one drawn here either, but these coefficients of 2, and when there's not one, indicate even when one is missing, there's not a number there, indicates the fact that there's one oxygen. So I would read this equation as 2 hydrogens plus 1 oxygen goes to form, or reacts to form, 2 waters. And that's how you would read this chemical equation right here. In addition, we can include things like states of matter. They're in parentheses usually after each compound, G for gas, L for liquid, S for solid, or AQ meaning a water solution or an aqueous solution. AQ stands for aqueous. You can also put into different symbols about what's going on. Usually these appear above the reaction arrow. We don't use these a whole lot, but they do happen. You have a delta sign, which is to symbolize the fact that the reaction was heated. Platinum or some other compound. And these, I don't have an example of these, but these would appear around the reaction arrow area of the equation instead of either reactant or product side. And so this is platinum, which is a common catalyst. And so these things would appear right here. There is a picture of that on page 64 of your textbook. It shows platinum as being a catalyst there. And that's all there is to this section 2.